What we're going to cover today is we're going to take a little look at battery chemistries. We're going to do a little contrast between lithium ion and lead acid chemistries. We'll hone in on a BMS. Exactly what is it? What does it do? We'll also look at open loop uh, versus closed loop communication with lithium batteries. And it could be lead acid as well. If it's lead acid, it's always going to be open loop. If it's lithium, then it could be closed loop. It could be open loop. So we'll take a look at that. We'll look at XW Pro with the HAB battery. You know, it's a great battery. We've been in the integration process for some time now, and we've got testing that's been done in the field, and it's looking really good. So we're comfortable with presenting these slides and just giving you an idea of how everything connects together, how it programs, and then of course setting up the XW Pro system in the way that you want to use it. And then finally, we'll take a look at some system photos. So a little contrast, lead acid with lithium iron phosphate. Lead acid is subject to temperature changes that affect the performance and lifetime. So, you know, that's why we ship the battery temperature sensor with the XW Pro in case you have a lead acid battery and you are in that area that gets cold in the winter and warm in the summer. If the batteries are located in an environment like that, then the battery temperature sensor adjusts the charge voltage to a higher level when it's cold and a lower level when it's warm. And that's because current flow is impeded when the temperature decreases, and it's increased when the temperature increases. Lead acid battery typically don't like to be discharged more than 50%, which is why when the sulfation occurs, you know, some batteries, lead acid batteries advertise, you know, carbon coating and different treatments that allow them to sustain a deeper depth of discharge. But as a general rule, 50% is the limit. If you go beyond that, then you're cutting into the life of the battery, or you'll have to equalize them more. And then you also have charging and discharging inefficiencies as well. They're not as efficient as a lithium iron phosphate battery. Now, regarding lithium iron phosphate, they do have a built-in BMS. So when we talk about safety, you know, a lot of people have been reluctant to go with lithium just because it's a volatile chemistry. They can catch fire. But I've never seen that happen with any of our systems. I've heard reports of it happening here and there, but you know, very, very rarely. And that's what the BMS is for. It's designed to monitor the cell temperature and then disconnect the battery from the load or the charging source if the cell temperature gets too hot, or if the voltage gets too high or low, or if the current is too high. Those are the criteria that would trip a BMS. They have greater energy density, so you know the kilowatt hours takes up less room when you compare it to lead acid. The partial state of charge tolerance is another great feature with lithium iron phosphate. They have better charging efficiency and offer up to 6 times more cycles than a lead acid battery. So when you talk about the cost differential between lithium iron phosphate and lead acid, you have to keep in mind that during the lifespan of a lithium iron phosphate battery, you could replace a lead acid battery bank up to 3 times. So what is a BMS? What does it do? So typically what a BMS has to do is protect the cells from over temperature and disconnect the charging source or the load. And it's also important that there's a pre-charge circuit built in, because XW Pro has a huge capacitor bank. It's 26 millifarads, which is equivalent to 26,000 microfarads of input capacitance. So the inrush current calculation is a capacitance times the delta of voltage divided by the delta of time. So when you close a switch, the moment the two contacts touch each other, then that determines, that's your divisor for your dV over dt. And when you multiply that capacitance, say, it's definitely not, when you first close the switch at a tenth of a second, you're looking at 12.5 amps. At the 100th of a second, it's 125 amps. When you're talking about, milliseconds on a scope, you can see that instantaneous value can climb very close to 1,000 amps, but it doesn't blow a fuse. And the reason why is a fuse requires a longer period of time for that current to be above whatever that fuse's rating is. So with the pre-charge circuit, it has a resistor built into it, and your time coefficient is your resistance times capacitance. So say if you use a 10 ohm resistor, in about a quarter of a second, it would reach a level where you would reduce that inrush current enough to go ahead and close the contactor and energize the capacitor bank of the Pro. So the BMS protects from thermal runaway. Closed loop controls the charge voltages. It's continually monitoring the voltage and making adjustments to prevent cell temperature from increasing. I have a lithium, a Discover battery here at my home. I've had it for about 5 years. As far as the voltage, when I first installed it, was about 56.7 volts is what the bulk charge was at. And after 5 years, it's only adjusted down maybe 0.7 of a volt. So right now it charges up to about 55.9. So over time, you're going to have a little bit of adjustment in voltage, but it's really not too extreme. And we'll talk a little bit about open loop and how to set up a system open loop to prevent nuisance tripping of the BMS a little later. And again, that's the whole goal of using a lithium iron phosphate battery with our products, is just preventing nuisance tripping. The BMS covers the safety factor. It's not going to allow the battery to get too hot. So when we're talking open loop, that means there's no communication between the BMS and the charger. You could use our battery monitor for state of charge control functionality with the Pro. The charging voltage is set manually per recommendation by the battery manufacturer, as well as how deeply they recommend that you discharge their battery. And by the way, we've been operating open loop with Simplify for many years without any problems. So closed loop is really a great feature. It's beneficial to get in and set the system up and be on your way without having to consider too much about what the voltages need to be set for and all that. But as long as you're setting up the system according to what the battery manufacturer recommends, most do support open loop as well. And then for closed loop, the BMS communicates with the charger. It always adjusts the charge voltage according to cell temperature, and as well, it manages the current from the XW Pro. And then the SOC is also reported by the BMS so that the Pro can use state of charge related functions. So the state of charge control allows for improved state transitions with XW Pro. We have many different functions that are based on state of charge now, which is optimal for lithium iron phosphate batteries. Because the voltage is so stiff throughout most of the range of state of charge, if you're using voltage alone, it's very difficult to tell what the state of charge is. It could be between 20 and 80% state of charge and only vary a couple tenths of a volt. So you also get optimized charging and battery over voltage protection. The XW approach follows the charge and discharge limits according to what the BMS dictates, and then it's designed to just prevent nuisance tripping of the BMS, and that's what it does. So we're talking about setup with the HAB battery, Marlon is a great resource over at Alti for any questions related to the HAB, but I'm going from the documentation of the HAB battery, and I'm also going off of experience in this field trial that we just finished up a few weeks back. So from what I understand, the HAB supports up to 14 batteries. For now, you'll want to just pair up the HAB with a single Pro. For multi-unit XW Pros, we still have a few different bugs to sort out there. It's not going to cause a problem other than we want to make sure that the settings fan out to all the slaves as well. So there's a couple of things we need to address there. So with single unit systems, you're fine, and with multiple batteries, you're fine. So you have a set of dip switches that you need to consider depending if you have a single HAB or if you have multiple HABs. So there's two versions of the HAB battery. There's version 3, which uses an Amphenol connector. The cable is supplied with the HAB battery. And then you have inside home indicated here, pins 9 and 11 are for RS-485 communication. And the Amphenol connector uses pins 2 and 3. So pin 2 goes to pin 9 on an inside home connector, and then pin 3 goes to pin 11. If you're using gateway or Insight Facility, it has a different connector with 2 different RS-485 ports. I'm just looking at RS-485 port number 1 here. So you would connect pin 2 to pin 18 and pin 3 to pin 20. With the version 4 HAB battery, they provide RJ45 jack for communication. So you're going to be using just simple Ethernet cables. So here, pin 2 of the RJ45 cable, or the Ethernet cable rather, is going to connect to pin 9 for inside home, and pin 1 is going to connect to pin 11. And then if you're using inside home or inside facility, then pin 2 will connect to pin 18 and pin 1 will connect to pin 20. So the next step in the process after you've established your hardwired connection is to go ahead and get logged into your Insight local device, whether it's Insight home or Insight facility. Both broadcast a Wi-Fi signal that does not require internet or anything. You just connect to Insight facility. It's broadcast as a wireless signal, and you have a password on the back of your Insight local device on a sticker, and enter that to get connected. And then you just simply enter the default IP 192.168.100.1 into your web browser. And this is the easiest way to commission a system as well, by the way, and especially if you're off grid or whatever. Sometimes they don't have internet yet at the site. So we don't require internet. You can get set up just by using Wi-Fi hotspot. So once you get connected, you'll be required to log in. Default username and password is indicated, admin, and then admin 123. You will be required to change the password. Once you get logged into your Insight local web page, you'll want to click the setup tab, and then you'll see the Modbus settings section. You'll expand that. You'll need to select the baud rate, which is 19,200, with parity is none and a stop bit of 1, and then go ahead and apply that. Next, you're going to need to search for the device. It has a range, a Modbus range. I typically use 1 to 63. I believe it's 1 to 10 for the HAB battery. You need to get confirmation from Alt-E on that. But at any rate, you can just enter the entire range, like 1 to 256, and it'll be in there somewhere. And then once it's detected, then it will show up as a device in your devices page. And then you can see on the lower right there how the battery is going to show up. It's going to show up as SE CAN, a BMS, and it'll show up along with all of the other devices that you have in your Pro system. Here we see a single Pro with a single high voltage charge controller. So now that you're connected and you've discovered the device, the final step is to run the BMS setup. So you click on setup and then BMS setup, and then you'll get a drop down menu that allows you to select the kilovolt HAB 7.5 from the drop down. And now, from what I understand, you're always going to select one battery because the kilovolt does the multiple battery calculations on its own. So you're not going to have to enter more than one battery here. And then go ahead and apply that, and then it'll indicate successful as a status after it's completed. All right, so let's talk a little bit about setting up your XW Pro system. So if you're on grid and you want to use your stored energy for, say, time of use, then and block the charging during a specific period of time, so you don't charge the battery with that power that costs more, you can block the charging during that period. And then, of course, your recharge SOC determines how deeply you want to load shave. So in this particular case, I have my system set up to discharge all the way down to 15%. I want to leave a little bit in case there's an outage. And then, of course, the SOC control needs to be enabled. That's done in the battery settings menu. You can see that once you apply the BMS setup that we outlined in the previous slide, it'll automatically configure the battery type for lithium ion, and it'll automatically configure charge cycle for external BMS. So you don't have to do anything there, but you can disable or enable state of charge control, and we recommend for lithium that you enable state of charge control. Now, all of the voltage controls in the system, except for high battery cutout and low battery cutout, are irrelevant. So your low battery cutout is still respected, even though SOC control is enabled. So if you don't have these backed off out of the way, you could get some nuisance tripping. So I usually recommend going up to, say, 60 volts for lithium batteries. And the low battery cutout is dictated by the Discover battery. So the high SOC cutout I have set up for 100%. The low SOC cutout I have set up for 10%. So it's going to load shave down to 15% and stop. If it stays that way long enough and the grid doesn't come back, it'll discharge down to 10% before it goes into a low battery condition. Next, you're going to enable grid support, and that your grid support SOC determines how full your batteries will remain when you're exporting to the grid. And then when you enter the load shave time period, that dictates how deeply you discharge your batteries down to the recharge SOC limit. Then of course you can set your maximum cell amps here, how much you want to export. And then your cell block is used in case you wanted to export during a certain period of time. You could do that at a certain magnitude. You could set up max cell amps to sell X amount of power during a particular block of time. Maybe you have some upstream loads that you want to shave. It's certainly possible to do that. So you have a wide latitude of different settings available for maximum versatility in how you want to manage your storage. So when we're running HAB battery with XW Pro, the charge controllers will still be open loop. So you can set those up according to what HAB recommends, kilovolt. They recommend no more than 56 volts for bulk and absorption. And then float, you can set to 54. You're always going to set the charge controller to 3-stage, because if you try setting the charge controller to 2-stage, then once the absorption stage is finished, it will stop charging. So just keep that in mind. So, and that's pretty much it. And you can use the custom battery menu to manually enter these values as recommended by HAB. And then finally, we have some system photos. Compliments Orlando Aquino, Caribbean Phoenix Technologies. These systems are in Puerto Rico. This is a single XW Pro with 2 MPPT60s and arc fault rapid shutdown with our DRS and 2 of the kilovolt HAB batteries. And here we have another single XW Pro system with a mini PDP and a single MPPT60 with a single HAB battery. And here's another, I believe that's the same one. Yeah, that's the same one. And here's a system with a single Pro and a single MPPT60 and 2 HAB batteries.